This video is entitled Normalization and the Physical Data Model and goes along with Chapter 11 of the book Introduction to Database Systems Modeling and Administration. I'm Dr. Reneau from Shawnee State University, and I'll be taking you through this video. Normalization is the process where we take a user's data, often a spreadsheet or some kind of semi-structured or mostly structured data, and we identify the entities within that spreadsheet or within that collection of data, and then we identify the relationships between all of the entities within the relationship within that data. The whole purpose of normalization is to take that, like say, big glop of data and try to figure out a good model that describes it that's going to work for the long term. There are three levels of normalization that are going to be discussed in this presentation. First normal form is, well, it's the first form of data normalization where we can get that spreadsheet or that table of data into a database. It's not pretty. There's a lot of redundant data. We've not identified all of the entities. We don't have all of the keys and foreign keys and all those things figured out, but it's at least into a database that we can start to use it. In second normal form, we eliminate what are called the partial dependencies, which are dependencies that are dependent upon part of the key we create in first normal form, and I'll talk more about that in the next slide. And then third normal form is where we take that database, where we take our data that's in second normal form with the partial dependencies. We then eliminate the transitive dependencies, which are other dependencies that are, we'll talk about those in the later slide. And once we're done with first, second, third normal, we should have eliminated most of our redundant data. We've created our various types of entities, our categorical entities and our transaction entities, our transaction detail entities, and our reference entities. We've identified all of those. We've created the relationships. We've identified keys, foreign keys, and we've got a good entity relationship diagram and a decent database structure at the end of this normalization process. So, first normal form. First normal form, imagine we have a spreadsheet of data with all kinds of columns and all kinds of stuff in that spreadsheet. Um, what we're going to try in first normal form is to create a single entity that describes that row of mixed up data. So, for instance, maybe that row contains customer number, customer name, order number, date, item on the order, another item on the order, and it's all in one giant row. Well, if we can get that into a database, even how ugly it is, even with all the redundant data, because what if a customer orders 5 times? Well, that customer name and shipping information appears 5 times. All the item details appear multiple times. You can see all the redundant data. But in first normal form, the trick is just get it in the database so we can start manipulating it. So we'll have a lot of redundant data. Maintenance will be difficult. To create a first normal form, we eliminate repeating groups. So if there's an attribute that contains more than one value, for instance, there might be an attribute called children that contains a name, comma, and another name, and a comma, and another name. For some customers, there might be no children. For others, there might be 10 children. You can see how we've got to break those out into separate columns, child 0 or child 1, child 2, child 3, and some people would have no children and some people would have multiple. We then split attributes that are not atomic. For instance, maybe there's a column that says city, state, zip, or city, state, and zip country. Well, we might want to break that up into 4 columns of city, country, uh, political district or state, and then postal code. So by breaking that one attribute, that one column, into multiple columns, we're a little smarter. We can slice and dice it a lot better. So we call those little bits, those smallest parts, atomic parts. So we would take that column. Maybe there's a column that's got last name, comma, first name, space, middle initial. Yeah, well, we want to break that up into three columns: last name, first name, middle initial. So we want to break things up into their atomic smallest parts. And then lastly, we need to identify a good primary key. We need to identify a key that would uniquely identify each row individually. In that one example I just gave, where we have an order on a single row with customer information, customer number, and item one and item two and item three, and all of that all the way across, what would be a unique identifier for each row? Well, the order number would, wouldn't it? Um, in other situations, though, we may need to concatenate multiple columns together to come up with a good primary key. We've talked about primary keys in previous chapters and what makes a good and a great and a okay primary key. We talked about the properties of primary keys. So just think about those, and hopefully you can identify a single column or two or three columns when concatenated together would create a unique identifier for each individual row in the data. And once we've got that, we're in first normal form. We can actually put that into a database. So how do we know we've successfully gone to first normal form? Let's go back through. We're successful when each row will be unique. So there aren't two rows that are the same in the new database table we're creating, and where the order of the rows and columns don't change the meaning of the data. So if the rows or columns get shuffled into a different order, or the rows get shuffled into a different order, no meaning is lost. And if we can get each row with a unique identifier, and each row is unique and has the order of the rows and columns doesn't mess up the data in any form or any way, then we're in a good, solid first normal form. We can get the data into a database. Again, lots of redundant data, hard to maintain, not optimal, certainly not optimal, but we can then start talking about moving into second and third normal. You can't go to second normal without being first normal first. Can't go to third normal without being second normal, without being first normal. So we've got to get to first normal first. Second normal form. So we have our data in first normal. It's in a database table. We've got a good primary key, maybe concatenated, maybe not. We've got everything atomic. We can shuffle the rows. Everything is good. Now, if we have a concatenated primary key, we need to find those attributes that are dependent on part but not all of that concatenated primary key. For instance, if we had a table of customers with their favorite items, so a customer would appear multiple times and their favorites would appear multiple times, or each, customer would have favorite A, customer would have favorite B, second customer would have favorite C and D, and you so we would find and say, well, the customer name and the customer address and the customer phone and email, well, that's not dependent upon the item number. That's dependent upon the customer number. So we would create a new table, a new entity called customer, and we would move the customer columns out of the main table into that new subtable and use a foreign key relationship to implement the one-to-many relationship between customer and our table. We would do the same then for the item or other attributes that we might have concatenated in our primary key. If we put a surrogate key in first normal form, we're already in second normal because there are no partial dependencies. And so that's second normal. I just want to stress this again: a partial dependency is a data field that's dependent on part but not all of a composite primary key, of a concatenated primary key. So if it's dependent upon, like, the customer is part of the primary key, or the item number is part of the primary key, or the state abbreviation is part of the primary key, great. We need to split that data out and remove that attribute from the primary key by implementing a foreign key relationship. So before we jump into third normal, I want to define what a transitive dependency is, because I'll be using that word a lot in the next slide. A transitive dependency is when a data field is dependent on a field that is not part of the primary key. So for instance, we brought all the customer information out into a separate table, but we have state abbreviation and state name. Well, state abbreviation and state name is dependent upon state abbreviation, not on the customer number. So you can see that would be what we call a transitive dependency. So third normal form is where we try to get rid of all of those transitive dependencies. So to go into third normal form, we have to take the structure from second normal, because if we've not gotten rid of our partial dependencies, we'll never move into third normal. Identify all of our transitive dependencies, and then move those transitive dependencies into their own tables using a foreign key primary key relationship to that new table to eliminate the columns in our table, previous table, and to eliminate all of the repeating rows. This video was probably pretty confusing, with all of the talk of first normal, second normal, third normal, transitive dependencies, partial dependencies, and all of that. I know this is probably overwhelming, but once you see some examples of normalization in the future videos, I think it'll all make sense. And you'll come back to this to get your definitions and to make sure you understand what these words mean. There are higher orders of normalization. There's a type of normalization known as a Boyce-Codd normalization, or some people call it 3.5 normal, that eliminates some additional things. There's fourth normal and fifth normal that are used in research and are used in some very specialized databases. But for most business applications, if you can get the data down to a good, solid, clean third normal, I think you'll find it works really well for most applications. This concludes our quick introduction to database normalization. Thank you for watching. If you would like this video and possibly subscribe, we'd really appreciate it. And I hope to see you on future videos.